This is Samuel Colvin, creator of Pydantic, creator of Monty as well, most recently. Also CEO of Pydantic, the company, creator of Logfire, Pydantic AI Gateway, Pydantic AI, and my boss. So please, everyone, a warm welcome to Samuel Colvin.
Thank you so much. Being Lais's boss is definitely the scariest of those things. Yeah, I'm going to talk about Monty, a project I started just at the very end of last year. I had a bunch of conversations with people, particularly at Anthropic, and got me thinking about what was going to happen. I thought soon, indeed I was right. And so soon after I'd had those conversations, a bunch of articles came out and code mode became a thing, or what is kind of now often referred to as code mode. So the principle here is that code execution, giving your agent the capacity to write code, is an excellent idea until you actually have to go and do it. Why is it a great idea? Well, there's a whole bunch of articles on it, but in particular, Cloudflare call it code mode. The idea that instead of exposing all of the tools that you want your agent to be able to call to the agent, you expose one tool, which is run code. And that code can effectively call those tools as functions. Anthropic call it programmatic tool calling, and also talk about using code execution in front of MCP. So instead of exposing all of the tools available directly into the context, you allow some code execution in between. There's even a coding agent called Small Agents from Hugging Face that's been around for some time that does a similar thing. The problem is, how do you go about running that code? You have a bunch of different choices for how you execute code. And so I call this continuum from impotence to chaos. But the idea here is that, like, actually, despite that, like, slightly aggressive and controversial name, everywhere on this continuum, there are useful things to be done. My point is not that there's no economic value at one particular point, but just that all these things need to happen. But basically, fundamentally, when we give more capabilities, when we give more power to what the coding agent can do, we basically forfeit control, and we increase the amount of context that we need to have. And lots of the tasks where using code is valuable are not full computer use. We do not need to be able to go and run bash and use pandas or polars or curl. We actually just need to be able to go and write a little bit of code, whether that be Python or TypeScript. Doesn't really matter. I think there are some compelling reasons why Python is slightly better, but it doesn't really matter, right? The point is, if we give the agent the capacity to go and run code, they can perform very well, even if you don't have, like, all of the libraries they might ever want to install. But in particular, if you want to go and do that, there is no trivial way to add to allow an agent to go and run Python code. We have the option of just running the Python code on the host where your agent is running. Well, that's kind of dangerous, because now that code can ultimately access everything that your agent can access. We can go and use the sandboxing services, which are kind of great, and that's what lots of people are using right now, and they're growing crazy. The reason they're growing is so fast is because it's actually quite expensive at scale. But it's a really big problem for enterprise. If you are a bank or a large hedge fund, you can't just go and, like, put your credit card into Daytona or Modal and suddenly have as many containers as you want. And so it's one of those bathtub situations where sandboxes are great for your, like, well-funded startup, but they're bad for someone who doesn't have the resources, and they're also really bad for enterprise. And so the idea behind Monty was to find a kind of middle way, a way where we could run Python code without all of the overhead of creating an entire VM, basically inventing a whole Linux machine just so that you can run some Python code. So Monty is a minimal, secure Python interpreter written from scratch in Rust, specifically to let AIs write code. So a very simple hello world example here. Here we are calling Monty from inside Python. So we can install it with Pydantic Monty. And here we have a very simple example where we're just doing hello world with an F string. And if I go and run this, it will run, and that is it actually running. The point is that the latency in particular of doing this, because Monty is running in the same process on the same machine as the agent, or as the code that's calling it, is in the order of 1 microsecond. Whereas when you're using sandboxing services, that's often 1 second. So we're getting kind of 6 orders of magnitude improvement in latency to start running code. So what exactly can and can't Monty do? It completely blocks access to all of the machine. The idea here is we have not taken CPython and basically chopped bits off it until we think it is safe. Instead, we started from scratch and built an entire new interpreter. So it lacks lots of features, bluntly, but it does mean there is no access to the file system, no access to environment variables, no access to third-party packages, no access to networking, unless you explicitly go and add those functionalities. And then we allow calling the rest of the environment via this callback system. But those callbacks are not the typical system where you would take a function pointer, pass that into Monty, and it would be able to go and access it. Instead, we do something actually quite like how coding agents call tools. We return from execution and say, please call this tool with these arguments. And that means that the host gets complete control over what it does at that point. And one of the other neat things, because we built Monty from scratch, is you can go and snapshot it. You can basically call dump, and you get back the binary representation of the interpreter, which you can go and put into a database. And again, that is orders of magnitude smaller than taking an entire VM and trying to like compress it and put it into object storage. So that gives us this kind of durable execution. I've talked about latency. Because it's just written from scratch in Rust, we can run it anywhere where we can run Rust code. We don't need Python. There's already a JavaScript library. There's a Dart implementer, a Dart SDK. Someone's implemented a Go SDK and a Kotlin SDK already. It's anywhere where you can run Rust code, you can call Monty. And the most important bit here is we don't need another sandbox. Or once Monty is matured, there is no need for an extra sandbox. You can go and run that code directly where your agent is running. But there is a trade-off. This is not designed to be an alternative to CPython. This is not, I am not suggesting you can take your Python code and port it to Monty and it's going to work. That is not a goal. There is a graveyard full of people who have tried to build alternative interpreters for Python, and they have all, for the most part, failed. Because to be a genuine, you can take your existing code that runs with CPython and map it into whatever other runtime, you need 99 point, a lot of nines of compatibility before that's really a credible thing to do. Monty is like not even 1.9, I would say, of compatibility. There's a lot of things you can't do, but if you tell the agent exactly what it can and can't do, it's amazing how far it can get. And so one other thing I didn't mention was it also comes with TY, the type checker from Astral, I suppose now from OpenAI, but hopefully it stays good, built in as well. So it can run type checking on your code before it runs it. In particular, it has its own version of typeshed, so it can specifically say to the runtime, you can't use X. So if you try to import a module that's not implemented, it will give you an error at typing time saying you can't go run that code. And so, yeah, I think it's important to say that like the golden rule is Python is the truth, and we speak nothing but the truth, but we are not trying to speak the whole truth. In other words, we're definitely not going to do anything that you can't, that is invalid Python, but there will be lots of things that are valid Python but don't work in Monty. So I don't know how I'm doing on time, but I'm gonna. Oh, cool! I've got some time. So I think the other kind of fundamental differentiator from this, and it's fair to say there are some other projects in the same vein. There's a thing called Just Bash from Vercel, which is a terrible misnomer. It is not just Bash; it is Bash and all of the, as much as possible of the Linux ecosystem of tools, because that's what you need to run kind of Bash-esque tasks. And there's another one called BashKit, but I think Monty is the only of the like, and there's also QuickJS, which is a similar kind of concept in JavaScript. But the idea with all of these projects is instead of taking something that exists and chopping bits off it until we hope it is secure, you start with something that can do nothing, and then you add functionality on to allow it to do things. That means that it will be more limited, but it means it should conceptually be safer long term. It's like having a whitelist rather than a blacklist. So quick demo here. Let me give some quick context for this demo. We had this happened to Pydantic AI's downloads. We suddenly had this like weird jump in the number of downloads in February. Like this is already, doesn't look like it, but this is already quite a lot of downloads. We're at like roughly 1 million downloads a day. And then suddenly there's into BigQuery myself and spend hours figuring out the SQL to work out what exactly went wrong. Or I could just go and give access to the SQL to a coding agent and go and ask it, basically figure out what happened. And that works pretty well. And in my particular case, I actually did this with Claude Code and it worked out. But if you were doing something equivalent in an application context, you don't need an entire VM to go and solve this problem. Monty allows you to basically run the SQL you need, process the data, investigate what's going on, loop over the output, and find out the problem without the need for a VM. So that's what we have here. I won't go through all of the code, but like one interesting thing we do here is we generate the stubs for the external functions that are available, and we add those stubs both to the context, the system prompt for the model, but also we use those stubs when we call the model as the stubs that are available when we do type checking, so that we can have full type checking, prompt about what the model can and can't do. We have a Pydantic AI agent that's ultimately going to go and run this code. But the interesting bit comes down here where we basically set up these 4 functions, which are what are registered. And these are the functions we say you can go and call them. So if you look at what they look like, we have the SQL query function here. Now, this is where it gets interesting, because I said that there's a very minimal amount of stuff you can do inside Monty. But that allows us, but that doesn't mean we can't use, for example, DuckDB, because we just register external functions that can do whatever you like within Monty. And now it can have gated whitelisted access to whatever you want it to have access to. So here we're going to use DuckDB to run some SQLs against the Parquet files. Plotting, again, obviously there's no matplotlib support within Monty, but we can have a function called plot, which allows it to go and generate a plot and output the image and even render it on screen from within Monty. A couple of others for showing plots and displaying a table, but you get the idea. And so ultimately our agent, which is iterating over until we get to the agent thinks it has finished, and then it will output and tell us what it thinks has happened. The actual running Monty comes here. We're going to run it like this. One of the things we discovered when building Monty was that coding agents are LLMs are very, very strongly trained to expect a REPL. E.g., when they are asked to run Python code, they assume that functions they've defined or variables they have defined in previous steps will still be available. And so we had to go and just implement the REPL inside Monty, because fighting the training of the models that they wanted a REPL didn't work. So that's why we're using REPL mode here. At the moment, I have to run type checking as a separate step, but that won't be around for long. And then obviously, if we get an error, whether that be a runtime error or a typing error, we just like serialize that error, give it back to the model and tell it, go figure it out. So if I go and run this example now, and the gods of demos are with me and I have internet connection, we will hopefully see what's going on. And so it will think for a bit, working out what Python it needs to run. And I'm going to be confident and say it's going to work at some point. Maybe Anthropic is down. Internet connection is there. It's thinking real long and hard. I can look actually inside Logfire at what's going on. And you see that it is indeed Opus that has been thinking for 28 seconds. Definitely didn't do this just before. I can actually do a Blue Peter style. Here's one I made earlier. If this decides it doesn't want to work, I can look at the previous run here, where you see that Opus thought for 3.8, you can see here, 3.3 seconds. And you can actually go and see the code that it ran. And so it's kind of quite interesting to watch the journey of the code that it went through. So you see here we have, the main prompt here where we told it what it can run, and we gave it the type hints to the external functions it could call, and then it output. You see the very simple SQL it ran at the beginning, got back some schema, some data about the schema of the SQL table, and it used that to go and run the queries. And I don't know what it's done. It's gone. Oh, it's now running, and it's. I'm going to start it again and hope for the best. I don't know what happened there. Because what it should be able to do, as well as the printing out the SQL it's running, it should be able to, now it's running. It should also be able to generate the charts to show you what it's looking at as it's going along. And you can kind of see the SQL it's generating, and you can see this is relatively sophisticated. This is not just, and it's printed out a chart of downloads over time as it starts to investigate. It can do relatively sophisticated things just with the amount of Python we have now, and we're adding more as we go along. But this is already powerful enough to do a whole range of tasks with external functions. It's already found that there was a spike in downloads of the metadata file, which is kind of the the telltale sign that this was some weird usage, not real downloads. So it will carry on and at some point finish and tell me that there was some weird spike in metadata downloads. But that's what I've got. Thank you very much. Any questions? I'm around at the end.
Wonderful. Thank you. Are you sure you have time for one question?
Oh my goodness, that's good timing.
If you want. You see, I see a few people trying to get in. Come on, give that.
Go on, one question here.
Yes.
Thank you. How far and where do you want to bring Monty to? What is the vision behind it in 5 years' time? Maybe
Oh, goodness me, goodness knows where we're going to be in 5 years' time.
1 year.
I mean, one thing I should have said that I didn't mention in this is this is not a slop fork of Python because it's not a fork. It is slop, right? As in, this is mostly AI generated, right? And this project would not be possible if it wasn't for the like leading models, which can go and like implement large chunks of it. I am not trying to go and build a CPython alternative. I am not going to go and add ABI compatibility so you can load third-party modules. I think there are definitely some obvious things we want to go and add, some other standard library packages, libraries. At the moment, there's no classes. It's amazing how far it gets without being able to implement classes because they're actually for much more like code design than actually this kind of execution still going. The number one thing we want to do is get it to the point of confidence where we can say it's no longer experimental and you can go and use it and run unsafe code, which at the moment we probably wouldn't give that guarantee. That's the number one goal. After that, good question.
How about external services? So external things working with Monty together.
Like what?
I don't know, any integrations?
I don't think we need them because the point is you can do external function calls for virtually anything. There are a few places where it would be nice to be able to wrap any arbitrary Python object and pass it in.
That's exactly what
that has some limits in terms of the durable execution context, but I think that would be a non-crazy thing to do, although definitely comes with like security concerns.
Thank you.
Should I stop there?
Wonderful. Thank you. Yeah, I think so. So thank you,
very much.
Samuel.